Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been studying proportional reasoning problems, and today's video will look at some problems that have maybe not nice numbers and some three-term ratios. The first problem I want to look at is a baseball problem. It says a baseball player has a home run to strikeout ratio of 3 to 17. That means for every 3 home runs she hits, she strikes out 17 times. So she's an all or nothing kind of player. If she hits 33 home runs, how many times did she strike out? Well, how many times did she strike out? There's our unknown. So we want to write let x equal strikeouts. And then we want to have our comparison. Now our comparison in this problem is we're comparing home runs to strikeouts. So we want to write that down. Home runs compared to strikeouts. And now we want to look for our numerical ratios. And in the problem, this one stands out pretty well in the problem. The strikeout to home run ratio in this problem is 3 to 17. Or it's the other way around, home run to strikeout, 3 to 17. And then for our second ratio to complete the proportion, we would put x as strikeouts on the bottom, because that's where strikeouts go in this comparison, and 33 home runs on top. After that, we want to make the connection between our top numbers. I can see that to go from 3 to 33, I times 11. So I'll do the same thing with 17 to get x. Now, 17 times 11, I would do that as 17 times 10 and 17 times 1. 17 times 10 is 170, and 17 times 1 is 17. You add those up and you'll have the total for 17 times 11. That's 187. So that means our x value is equal to 187 strikeouts. That's a lot of strikeouts. There wasn't anything really not nice about that problem. I guess it just involved a little bit of bigger multiplication there. So we actually did a strategy like this in one of our mental math classes this week where we practiced this a bit. Man, if you can do your basic math facts, you can do almost anything in math. Let's take a look at another problem. This one is a three-term ratio. It's a breakfast cereal problem. It says a breakfast cereal contains corn, wheat, and rice in the ratio 3 to 4 to 2. If a box contains 225 grams of corn, how much rice and wheat does it contain? Well, the unknown is how much rice and wheat. We actually have two unknowns. So we'll say let's say let R equal rice and let W equal wheat. We have to give a different variable for each unknown. Now our comparison in this problem is pretty obvious. We're comparing corn to wheat to rice in that order. So the cereal has 3 parts corn, 4 parts wheat, 2 parts rice. Let's write that comparison down, but we'll shorten it up. We'll call it C for corn, to W for wheat, to R for rice. That's the order our ratio has to go in. So that's the ratio given in the problem. That's pretty obvious right there. So for our numerical ratio, we'll say that that's 3 to 4 to 2. But now to complete the proportion, we have to make another ratio that makes that comparison. Well, you can see the first part of our ratio has to be corn. And in the problem, it says we have 225 grams of corn. So 225. Next comes wheat. Wheat is one of our unknowns. Wheat is W, and last comes R. R is rice. So we'll finish the proportion by saying wheat next, W, and then R. And right here is our proportion, 2 equal ratios. Now we want to focus in on the first number, the 3, and the 225, the first number of each ratio, because that's going to help us solve it. What do I multiply by 3 to get 225? Well, I'm going to use some mental math skills here. I know 3 times 70 is 210. 3 times 7 is 21. 3 times 70 is 221. I'm going to just guess then that 3 times 75 will be 225. Well, I know 3 times 70 is 210 and 3 times 5 is 15. So 3 times 75 is 225. That means to get the value of W, I'll do 4 times 75. And to get the value of rice, the last term in the ratio, I'll do 2 times 75. Okay, and let's take a look at those values. Well, rice, R, will be equal to 2 times 75. Well, that's 150 grams. And wheat, which was 4 times 75, has to be double 2 times 75. So wheat will be 300 grams. And then we have all the components of our cereal. Sounds like an exciting cereal. When I was a kid, we eat things like Cookie Crisp and Boo Berry cereal. A lot less healthy, but a lot more fun. Cookie Crisp was basically just milk and cookies. Like, whoever thought of that cereal? That's a 3-term ratio. Let's look at another one. So it's another sort of breakfast situation. The ratio of bananas to yogurt to juice in Addison's favorite smoothie, that's one of my daughters, is 5 to 4 to 1. How much banana and juice is in her smoothie if it has 320 grams of yogurt? Well, first thing I talked with about the kids is this ratio for these ingredients. Are you really going to get a smoothie? 5 parts banana, 4 parts yogurt, 1 part juice? That's going to be really dense. You'd probably want to reverse this. You'd probably want 1 part banana, 4 part yogurt, 5 parts juice, or some water. But, it's good to talk about these things and think about the situation. But let's solve it the way it is. So the question says how much banana and juice is in her smoothie if she has 320 grams of yogurt. So we'll say let X, or let's do let B equal bananas, and let J equal juice. And then the comparison we're making is bananas to yogurt to juice. So let's shorten that up a bit and say B to Y to J. And that ratio is given in the problem as 5 to 4 to 1. And now we have to make a second ratio using our unknowns. Well, we are given first that bananas come first, and bananas is one of our unknowns, so that we'll start with B. We are given that yogurt comes next, and yogurt is known. In the problem it says we have 320 grams of yogurt. So 320 would go next. And then juice is the last part, and we are given that juice is J. Juice is one of our unknowns. So to solve this problem, I have to look at the second term of each ratio. What do I do to 4 to get 320? Well, I know 4 times 8 is 32, so 4 times 80 will be 320. So I'm going to do that to get my parts. I'm going to do 5 times 80 to get bananas, because that's the first term in each ratio. And I'm going to do 1 times 80 to get the juice. Okay, well, let's do bananas first. Bananas is 5 times 80. Well, 5 times 8 is 40. Tack on a 0 for 400 grams of banana. And then the juice, we wouldn't actually measure the juice in grams. Juice would be measured in milliliters, and that's 1 times 80 for 80 milliliters of juice. And as I said, I don't think this is going to make a very good smoothie. But that is the amount of ingredients we would put in. Okay, let's look at a problem now that doesn't have nice numbers. It says Randy Bobandy made 9 scarves from 4 meters of fabric. How many scarves can she make with 37 meters of the same fabric? Well, we're being asked how many scarves can she make. So let's say let X equal scarves. And in the problem, we're comparing scarves to fabric. So we'll want to write that as our ratio. Scarves being compared to fabric. And so we want to look for numbers in that problem that make that comparison. I see 9 scarves compared to 4 meters of fabric. So 9 to 4. And for our second ratio, our unknown is scarves, so unknown will be X. And we want to know how many scarves we can make with 37 meters of fabric. You can see that comes right from the problem. Now here's the issue. This one's a little trickier to solve. What do I multiply by 4 to get 37? You don't know that. So you can actually do, to get that number that you multiply by, you would do 37 divided by 4. I let the kids use their calculator for this one. And 37 divided by 4 is 9 and 25/100ths. It's 9.25. Which means to go from 4 to 37, we would multiply by 9.25 and do the same thing to the top. Multiply by 9.25. And when we do that, our value for X would be 83 and 25/100ths. Now that's supposed to be the number of scarves. So what this means is we would have 83 full scarves. And then just a little bit of another one. Okay, let's look at one last problem that follows this idea where the numbers don't work out nicely. It says a 20-meter building casts a 12-meter shadow. If this proportion stays the same for all objects, what is the height of a tree with a 3.8-meter shadow? So we would start off with our unknown, let X equal height of tree. And what we're comparing here is we're comparing object to shadow. Now the first object is a building, a 20-meter building that casts a 12-meter shadow. And we want to know the height of a tree that casts a 3.8-meter shadow. Well, tree is the object, so object goes on top, so that would be our X. And we're given that the shadow of that tree is 3.8 meters. Now check this one out. This is a really tricky one here. We need to figure out how we can go from 12 to 3.8. Well, we're going to have to divide by something. What do I divide by? Well, to figure out what I divide by 12 to get 3.8, I'm going to actually divide. I'm going to do 12 divided by 3.8. And when I do that, I get 3.157947. Let's say that that's about 3.15 or 3.16. So I'm actually going to divide by 3.16 to get 3.8, approximately. I'll do the same thing to the top. Divide 20 by 3.16. And when I do 20 divided by 3.16, I get that X, and since I was rounding off some numbers here, X is approximately 6.3 meters. So that means the tree would be about 6.3 meters tall. And that's approximately, right? Because we were rounding some things off. I hope that helps you with today's assignment. That's all for now. Flexing Teacher Weber, out.